Mark Houtz. I'm a network engineer for a bunch of school districts up in Utah. I'm largely in the wireless Wi-Fi private cellular side. I do a little bit of edge. That's why I'm here. But I had a thought about something that I tested about 2 weeks ago with the group I'm a part of. I posted about this and there's been a lot of interest in it. So I was like, why don't we just give a quick presentation here about it. In the private cellular world, we have what's called CBRS, operates in band 3.55 gigahertz to 3.7. Here in the United States, it's being explored in other countries, but largely it's really starting here in the States. It's been around, you've been able to build them for a long time, but it's just access to spectrum has been the limitation, and we're starting to get some access to that around the world. Recently, I live near Salt Lake City. Just west of that, about 2 hours, hour and a half, 2 hours, is what's called the Bonneville Salt Flats. It's an area that is super flat. It's a lake bed that is covered in salt. If you're wanting to test things at distance or at speed, this is the place to go. This is about quarter mile or half mile away. You can go and go and go and it's just flat forever. Bonneville Salt Flats is best known for this. Land speed records have been set here. I don't know, I just Googled a quick image here, but the land speed records have been set here. They go hundreds and hundreds and hundreds of miles per hour across the salt and have been able to break the sound barrier and set a lot of speed records. Our goal with this was to set a different type of speed test record, but with different wireless technologies. I did about 2 years ago, a buddy of mine, Fernay Munoz, and I went out to the Salt Flats, and another buddy, Jason Iyer, and we all went out to Salt Flats and did some testing. We had the antenna at about 15 feet off the ground, and we got about 2 miles out of the private cellular CBRS spectrum band. We thought it was pretty cool, but we're like, there's definitely limitations. It was a last minute project. We just kind of did a last minute testing. So we're like, let's go back out there and do some more testing. And so we had some different options. I brought my one wheel and was just riding along on my one wheel out there. This was just me testing the Homina Nomad with Wi-Fi. Wi-Fi doesn't go as far, so it was a lot shorter. But testing the Wi-Fi on this piece. Then to improve things, our first time out there, we just had a mat or a tripod. We stuck some radios on. This time we had a cellular cow. That antenna is 60 feet in the air, much better than the 15 feet we got from the first test. So we're able to put the antennas up higher to see if we could get better distance. I also brought Wi-Fi Halo. It operates in the 900 megahertz spectrum. And so I had a Wi-Fi Halo antenna up there I was playing with as well. Just really fun to just kind of test things. We used Starlink as the backup or the backhaul. We also had AT&T and T-Mobile as backups, but we were mainly using Starlink. And then we had 2 bi-cells radios. We had a LTE, 4G LTE, and a 5G radio. So we're testing both LTE and 5G on the flats. Spectrum-wise, they went about the same distance that I'll get to in a minute. But there's the Halo antenna, as I mentioned. This thing was not as high, so there was definitely some limitations. There's a group called Morris Micro that said recently got 15 kilometers out of Wi-Fi Halo. Previously, they had hit 3 kilometers. I was hoping to get 3 kilometers, but didn't quite get that far. Our main test device or unit was side-by-side, just flying across the flats. We didn't have any super fast cars, sadly. And most people didn't want to get salt all over their cars. So we just took the side-by-side out and just went flying along. And for testing options, I had a Spectran V6 spectrum analyzer. This thing can sweep super fast across it can, if you have the right licensing, you can get terahertz of sweep off this thing. Crazy fast device, but that was one of the main ways I was testing, seeing what was on the spectrum. I've also been, this is at my house, but this is what this software looks like. I didn't get a good picture of it on the flats. I did video and stuff, but I couldn't get it on the slide quick enough. But you get the spectrum analysis, and then on top of that, I've been building this device. It's called with a WLAN Pi. It's got a 5G modem on the back that I've been playing with and building some different tools to kind of capture some of the private cellular and regular cellular bands out there, and graphing them into really cool Grafana dashboards and fun little things like that. So at the end of the day, when we were done with our testing, on the Wi-Fi Halo side, I got about a mile. Not the 3 kilometers I was hoping, but I think part of that was height, amongst some other things. The antenna I had probably was not great for the going distance. On the CBRS LTE and 5G side, we got 4 miles. Typically on our deployments of private cellular, we're getting about a mile. We've actually hit 12 miles once off private cellular in a like pristine, really, we were shocked use case. But about 4 miles is kind of what we're expecting of usable signal. We were able to do speed tests at that distance and actually browse the internet and things like that. Some findings with this is height is super important when you're building antennas, as many of us know. Getting line of sight and obstructions is definitely important. So get that antenna as high as you can. Cool other thing is the Bonneville Salt Flats are about speed. We were flying along and you had full connectivity flying along in a car. You don't get that with Wi-Fi or some of the other wireless technologies. And then since we're at Edge Field Day here, I just want to throw in this little piece. Edge computing can be put in the cow. So you have the radio at the cow or the cell site, or it's even possible to put it on some of the UEs at the client side. So you can handle some of that processing at that side. So, and that's all I got. Thanks.